Welcome to Modeling Mastery, the podcast where we explore the art and science of software design. I'm Hex.
And I'm Byte. In our last chapter, we took a close look at the entity, the tactical building block that is defined by its unique identity and thread of continuity.
That was the first of the core patterns of tactical design. Now in Chapter 6, we explore its essential counterpart, the value object. This pattern is the key to creating models that are not only powerful, but also simple and maintainable.
It's so important because it provides the antidote to entity think, the tendency for developers to give everything a unique ID and a complex life cycle. This chapter is all about concepts that measure, quantify, or describe things in the domain.
We will learn the key characteristics that define a value object, such as immutability and value equality, and see why the book advocates for using them as much as possible to simplify our designs.
It's time to model the other half of the domain. Let's jump into our first episode for Chapter 6.
In our last set of episodes, we focused on the entity, an object defined by its unique identity. But a model composed only of entities would be unnecessarily complex. To balance this, we need its counterpart, the value object.
This is such a critical topic, Hex. The book points out a very common trap developers fall into called entity think. Because we're so accustomed to mapping every class to a database table with a primary key, we instinctively make everything an entity. This adds a huge amount of accidental complexity to our systems.
A value object provides the way out of that trap. It's not a thing that you track over time. It's an object that measures, quantifies, or describes another thing in the domain. Crucially, it is defined by its attributes, not by a unique, persistent identity.
Money is the perfect real-world example. If I have a $5 bill and you have a different $5 bill, we don't really care about their unique serial numbers. For the purpose of a transaction, they are completely interchangeable. Their identity comes from their value. This is the principle of value equality. Two value objects are considered equal if all their constituent attributes are equal.
This leads directly to the second defining characteristic of a value object. It must be immutable. Once you create an instance of it, its state cannot be changed. If you need a different value, you don't modify the existing object, you create a new one and replace the old one entirely.
And that immutability makes them incredibly safe and simple to work with. You can pass a value object around your system with absolute confidence that it won't be modified unexpectedly. The book compares it to moving to a language with garbage collection. It just removes an entire category of problems you have to worry about.
So the core guidance is to constantly challenge our assumptions during modeling. Does this concept truly need a unique identity and a complex life cycle to be tracked over time? Or can it be modeled as a simple, immutable description?
Exactly. The book's advice is clear. We should strive to use value objects wherever possible. They are fundamentally simpler to create, test, use, and maintain, and they lead to cleaner and more robust domain models.
We've established that a value object is defined by its attributes and is immutable. Let's delve into another of its core characteristics from the book. It must model a conceptual whole.
This is a crucial point. A value object isn't just a random bag of properties. Its attributes must come together to form a single, cohesive concept that has meaning in the ubiquitous language. The book's example of money is perfect for this. An object shouldn't have separate amount and currency attributes. Instead, it should have a single property, perhaps called worth, which is a monetary value object. That monetary value then encapsulates both the amount and the currency as a conceptual whole.
This principle encourages us to find these rich concepts everywhere, even when we might initially see only primitive types. A simple string representing a person's name, for instance, could be better modeled as a full name value object. This new object can then be responsible for all the logic related to name formatting or comparisons, centralizing that behavior instead of scattering it across client code.
And because it's a conceptual whole, when a value needs to change, we use the characteristic of replaceability. You don't modify an attribute inside the existing value object. You create an entirely new instance with the new value and replace the old one completely.
This idea of creating new instances instead of modifying existing ones is the essence of another key characteristic, side effect-free behavior. Methods on a value object are functions. They can take input and produce output, often a new value object, but they are forbidden from modifying their own state.
The book has a great fluent example of this in code. Instead of a typical setter like name.setMiddleInitial, you'd have a method named name.withMiddleInitial. This method doesn't change the original object at all. It returns a brand new full name instance that includes the middle initial. It's expressive, and because it doesn't cause any side effects, it's completely safe.
So when we bring all these characteristics together, a conceptual whole, immutability, replaceability, and side effect-free behavior, we have an incredibly powerful and simple modeling tool. It allows us to capture the descriptive aspects of our domain in a way that is robust, expressive, and far easier to maintain. These characteristics make value objects incredibly useful, not just inside a single model, but especially when we need to integrate between different bounded contexts. The safety and simplicity of an immutable value stand in stark contrast to the complexities of distributed systems.
This is one of my favorite patterns in the book because it's so pragmatic. It's called integration with minimalism. When your bounded context needs information from an upstream system, a common mistake is to create a local entity that mirrors the structure of the upstream object. This immediately saddles your team with the huge responsibility of keeping that local copy synchronized, which can be a massive headache.
The minimalist approach, using a value object, avoids this entirely. You create a simple, immutable object in your own context that captures only the essential descriptive information you need from the upstream system, and nothing more. The Saussovation case study provides the perfect example for this. The upstream identity and access context has complex user and role aggregates, which manage life cycles, permissions, and state changes.
Right, those are full-fledged entities, but the downstream collaboration context doesn't need any of that complexity. It just needs a description of the person who is performing an action, like posting to a forum. So its anti-corruption layer doesn't try to replicate the user aggregate. Instead, it queries the upstream service and translates the response into a simple, immutable author value object. It just takes the name, identity, and email address it needs for descriptive purposes and ignores everything else.
This is a conscious architectural trade-off. By modeling the collaborator as a value object, the collaboration team accepts that the data might become stale. If the user's name changes in the upstream system, the old author instances in the collaboration model won't automatically update. But what they gain in return is immense simplicity. They are freed from the responsibility of listening to update events and managing a complex synchronization process. The value is treated as a snapshot in time.
And that's usually the right trade-off. It keeps the downstream context clean, decoupled, and focused on its own core responsibilities. This minimalist integration is a cornerstone of a healthy anti-corruption layer.
This leads us to another powerful everyday use case for value objects, modeling what the book calls standard types.
Most developers will know these by other names like type codes or lookups. They are concepts used to classify or categorize other objects. Think of a phone number that needs a phone number type. It could be home, work, or mobile. These aren't unique things with their own life cycle. They're simple, descriptive values from a known finite set.
Exactly. The book points out an important architectural consideration. In a large enterprise, these standard types are often managed as entities in a central bounded context, which acts as the system of record. That system might have a UI for adding new currency types or medication routes. However, from the perspective of our consuming bounded context, we don't care about their life cycle. We just need to use them as descriptors.
So, following the principle of minimalism, we should model them in our context as value objects. And for many platforms, the simplest, cleanest, and most robust way to implement these standard types is with a built-in language feature, like a Java enum.
An enum is a perfect fit. It satisfies all the characteristics of a value object. It represents a conceptual whole, a finite set of named values. It is inherently immutable. Equality is based on the specific instance, which is value equality, and importantly, you can attach side effect-free behavior to it.
The group member type enum from the book is a great example of this. It has two values, group and user. It also includes methods like isGroup. The default implementation returns false, but the group instance overrides it to return true. This is a very clean use of the state pattern, where the behavior is directly attached to the value itself. It's a lightweight, type-safe, and highly expressive way to bake these classifications directly into the ubiquitous language.
We've thoroughly explored the theory and characteristics of value objects. Now let's discuss the practical side, how we test, implement, and, most importantly, persist them.
The book advocates for a test-first approach, and I think its strategy for testing value objects is brilliant, because it's not just about finding bugs, it's about proving the core characteristics of the pattern. The process is simple. First, you create an instance of your value object. Second, you create a copy of it, often with a copy constructor. Third, you assert that the original and the copy are equal.
That establishes the baseline for value equality. The next step is to execute one of the object's behavioral methods, a side effect-free function. You assert that the result it returns is correct. And then comes the most critical step. You assert that the original object is still equal to its copy. This single test elegantly proves the correctness of the behavior, the implementation of value equality, and the guarantee of immutability all at once.
This testing strategy naturally leads to a clean implementation. A well-designed value object will have a primary constructor that takes all the state necessary to create a valid whole value. It will also have correctly implemented equals methods and hash code methods based on all of its attributes, which is the mechanism that makes value equality work. It should have no public setter methods, preserving its immutability.
Now for the final and often trickiest part, persistence. The key principle here, as the book emphasizes, is to reject the undue influence of the data model. Our domain model should drive the persistent schema, not the other way around. For a single value object property on an entity, the ideal approach is denormalization.
Exactly. You store the attributes of the value object directly as columns in the table of its parent entity. In an ORM like Hibernate, this is achieved using a component mapping. This tells the ORM that the business priority object, for example, is not a separate tracked entity, but is simply a component of the backlog item. This is very efficient because it avoids database joins.
The real challenge comes when an entity needs to hold a collection of value objects, like a set of group member objects. How do you store a list of things that don't have their own primary keys? This is where the object-relational impedance mismatch is most apparent.
The book provides a very pragmatic solution to this. You acknowledge that for the persistence layer to function, the group member needs to be treated like an entity in the data model. So you give it a hidden surrogate ID, a primary key that only the database and ORM care about. However, in your domain model, the group member class remains a pure, immutable value object with no knowledge of this surrogate ID. This allows the ORM to manage a standard one-to-many relationship without forcing you to corrupt your domain model with persistence concerns.
And that is a perfect example of a practical compromise that honors the principles of DDD. It isolates the technical complexity required by the database while keeping the domain model clean, simple, and expressive. It truly demonstrates the power and versatility of the value object.